Okay, and this is then AQA 20 per 3 higher. So let's make a start. Number one, what does AUB? So this is talking about Venn diagrams. So if you've got Venn diagrams like so, we've got circle A, circle B. This means A or B. So we've got it's in the A circle or it's in the B circle. So it's A or B or both. Number two. Okay, circle the equation that is parallel. So if we've got any straight line, it's of the form y equals mx plus c, where m, the number in front of x, is our gradient, in effect how steep our line is, and our c is our y-intercept, so where does it cross the y-axis. So if we've got an equation y equals half x plus 3, the gradient of this line is a half. So if we want something that's parallel, well, if they're parallel, you know that the gradients must be the same. So we're looking for any of those equations with a gradient of a half, and so it is actually just going to be y equals a half x. Number 3 then, so work out 320 as a percentage of 80. So this is slightly awkward. It's 320 over 80, and we want it as a percentage, so we're going to times that by 100. Now it's a calculator paper, so I'd be stupid not to use it, to be fair. So if I just type that into my calculator, I get 400%. Is that an option? Yes, it is. So I'm going to be fairly happy that I've got that one correct. Number 4. So what have we got here? Fair coin is spun 4 times, probability of getting 4 heads. Well, the probability of getting it once is a half, but because we're rolling it 4 times, I'm just going to do half, multiply by itself 4 times. Multiplying fractions, you just multiply the numerators together. 2 times 2, 4, 8, and then you multiply the denominators together, so it should be 1 over 16. Number 5. To the nearest 1,000, okay, whenever you see to the nearest 1,000, it's going to be upper and lower bounds. So we've got 18,000 people at a festival. Now, ordinarily, what I'd do is I'd say, well, if it goes up in, it says to the nearest 1,000, well, I'm going to put the 1,000 below and the 1,000 below, 1,000 above, and I just work out what's in the middle. So it's going to be 17,500, 18,500. And 9 times out of 10, that's going to be what you need. That's the lower bound and that's the upper bound. However, with this one, because we're talking about people, we just need to make sure that we're getting it correct. So the first one says, what is the minimum number of people? Well, 17,500. Because if we have 17,500, that's going to round up to 18,000. But the largest amount, well, if I had 18,500, that would round up to 19,000. So the answer that they're expecting you to put here is 18,499. Slightly awkward because, like I'm saying, it's not lower bound or upper bound. For example, what they often ask you to do is something like this. So it's bigger than or equal to 17,500, but less than 18,500. So usually those two numbers just come from your number line. But because we've got people, if it has to be less than 18,500, in effect, the maximum number of people is going to be 18,499. Hopefully that made a bit of sense. Number 6 then. So let's have a look at this one. So this one's going to be slightly harder for me to show you, but hopefully you get the general idea. So we've got our quadrilateral that looks, I don't know, something like this, maybe something like, I don't know, like that. So we've got A, then we've got B, then we've got C, then we've got D. It says there's a path across the field that starts at B, okay, it's easy enough, is the same distance from BA, so it's from BA as it is from BC. So what we need to do is in effect split this in half so that the field goes between, so it's the same distance from BA as it is from BC. So the way that you do that is you get your compass. Imagine my fingers are the compass. You put your point on B, and you're going to keep the width the same, and you're just going to rotate it around like so. So in effect, you're going to have a little arc here and a little arc here. So the width is the same. What you can then do is you can then move the width of the compass slightly more, put your point on this, draw a curve. Now without changing the width, put your point on this line and then cross. And what you'll have is two arcs that look like that. You can then get yourself a ruler and I mean that's terrible, but hopefully you get the idea. You go straight through that point of your cross, and that's called bisecting. So we've basically split this angle exactly in half. So anywhere on this point, you are the same distance from A as you are. In fact, is that right? Yeah, so it's the same distance from BA as you are from BC. Okay, number 7. Use Pythagoras. They hardly ever tell you what topic to use, so you're quite lucky in this sense. This is very straightforward. So Pythagoras is a squared plus b squared equals the hypotenuse squared. So I'm going to call it h because it's the hypotenuse. The hypotenuse is always opposite the right angle, and in our case that's x. And a and b, it doesn't really make any difference because we're just squaring them and adding them together. So let's say that 32 is a, and is it 60 is b. 32 squared add 60 squared equals h squared. Add those up, may as well just type it in. So 32 squared add 60 squared is, wow, just an annoying number. 4,624 is h squared. The opposite of squaring something is square rooting. Again, just type that into your calculator and you get 68, and the units are centimeters. So that should be fairly straightforward. Number 8. Okay, Chris visits a library, cycles. So what have we got here? We've got a distance time graph. So distance time, then it's speed time, then it's acceleration time. These are kinematic graphs, okay? You don't really need to know what they're called, but I just prefer to write them like this. Now, on a distance time graph, the gradient gives you the velocity. On a velocity time graph, the gradient gives you the acceleration. If we go the other way and we find out the area, so the area under an acceleration time graph gives you the velocity, and the area under a velocity time graph gives you a distance. It gives you the distance. So in this one, it says he cycles to the library in half an hour at a speed of 12 miles per hour. He stays at the library for an hour because we can see that the distance isn't changing because we've got something like this. So we've got it stays there and then it comes back down again. Okay. This is our distance. This is our time. What's this? May as well just finish it off. 9 o'clock. This bit here is 9:30. This bit here is 10:30. And then this one is 11:15. But what are we actually doing? He then cycles home, blah, 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 blah. Work out the speed in miles per hour where he cycles home. So, distance away from home. So he starts here, travels away from his home. His distance doesn't change here, but the time still continues. So you know that he must be at the library here. And it even says for 1 hour, 9:30 to 10:30. Then it says he cycles home. So he cycles home must be this part here, right? And there's different ways that we could do this. I've just told you all of this, so I may as well just teach you that. The gradient of a distance time graph gives you the speed. So if we just make ourselves a little triangle here, we've got, how far have we gone? We've gone 45 minutes, which is 0.75. So our little triangle is 0.75 hours. The distance that we've gone, I'm making a right pig's ear of this, aren't I? He cycles to the library in half an hour at a speed of 12 miles per hour. So if he goes 12 miles in 1 hour, in half an hour he must have gone 6 miles. So that distance there must be 6. So this triangle here, he's gone 6 miles in 0.75 of an hour. So my gradient is going to be the change in y divided by the change in x. Type that into my calculator. I'm really hoping that that one is correct. And we get 8 miles per hour. Okay, there are other ways, and you've probably torn your hair out listening to my explanation there, but hopefully that helps some of you. Okay, what question are we on now? I believe we're on question 9. So let's have a look at number 9. These two triangles are similar. Okay, if you've got, just out of interest, if you've got two shapes that are similar, that just means that one is an enlargement of the other. And again, it can be bigger or smaller. But basically, the angles are staying the same. You don't change the size of the angles. So if that's 20, that's 12, and that's 16, and we're trying to work out x there, y there, a there. We're trying to work out all of it, work out the value of a. So what two lengths correspond? Well, we've got 20 and 16, haven't we? So what I would do is, to work out the scale factor, I'd go, well, 20 divided by 16. I'd do the bigger number divided by the smaller number. Type that into your calculator, and you get a scale factor of 1.25. So to go from the small triangle to the big triangle, you multiply by 1.25. So to go from the big triangle to the small triangle, you're going to divide it by 1.25. So to work out A, I'm going to do 12 divided by 1.25, which should give me 9.6, and the units are centimetres. Okay, so you've got 9.6 centimetres. Number 10, there's a bit here that might just trip you up. So hopefully if you expand that bracket, you get 8c plus 12 minus 5c. Everyone will do that. But then you also need to do minus 1, in effect, times minus 1, which will be plus 1. Okay, so you have to multiply that bracket out correctly. 8c minus 5c is 3c. 12 add 1 is 13. So we just had that bit here, minus 5c minus 1. When you expand that out, you get minus 5c. But this number in here is 1, basically. So you've got minus 1 times minus 1. And negative times a negative is the plus 1. So that second part of the question is probably just going to have tripped you up, potentially. Number 11, then. A spinner can land on red, blue, or green. After 350 spins, relative frequency of red is 0.18. So red is 0.18. Blue is 0.62. Work out the number of times. Right, so this one you just do your relative frequency, 0.18, times the number of spins. Again, you've got a calculator, so you'd be a fool not to use it. So there's going to be 63 reds. 0.62 times 350 is going to be 217. Add those together, you get 280. We've rolled it 350 times. So take away those and you get 70. Okay, so that's how you do that question. Number 12 says, here is some information about 26 houses. Okay, so 26 houses, A, B and C are all different numbers. The median must be 3.5. Work out a possible set of values for A, B and C. So the median then is the middle number. And if you have an even number of houses, it's slightly more difficult to work out. But I mean, in effect, to work out the median, you have your number. The trick is to add 1 and divide by 2. So say, for example, you had your 5 fingers like this. The middle one, well, we've got 5, add 1 is 6, divided by 2 is 3. So that's going to be your middle finger. Right, so it works with odd numbers, but it also works with even numbers. So in this case, we've got 27 divided by 2, which is going to be the 13.5th number. So in effect, what that means is that the 13th number must be a 3, and the 14th number must be a 4. Because then when you work out what the median is, well, it's going to be halfway between 3 and 4, which is 3.5. So with that knowledge then, we've got 7 houses with 1 bedroom. So let's write this out. 1, 1, 1, 1, 1, 1. How many is that? 3, 6, 7. Now I then need to get up to 13. Let's do it from the other way as well. So we've got 8 5s. So 5, 5. I'm probably making a long-winded way of doing this, but hopefully it's useful. So we've got 1, 2, 3, 4, 5, 6, 7, 8 5s. So we've got 7 1s, 8 5s. How many did we have to start with? 26. So we had 26 houses to start with. So now we've got 18. So this is going to be the 8th number, isn't it? And then this is going to be the, whatever that is, 18, 17, 18. I think that's going to be the 18th, 19th, 20, 21, 22, 23, 24, 25, 26. Wow, I need to get my brain in gear. So we just need to work out how we can get the 13th number to be a 3 and the 14th number to be a 4. So what we've got, have we got any other information? Have we got any other information? Okay, well, one of the ones that I've worked out, and you're all going to have different answers. If you have 5 twos, so you've got 1, 2, 3, 4, 5. If you then have 1, 3, that should hopefully be the 13th. So we've got 7 1s, 5 2s is going to be 12. So the 13th number is going to be 3. That works. And then the C would have to be 4s, wouldn't it? Because we can't have any more 5s because we've only got 8 5s. So we'd have to just have the rest of them as 4s. And that would be the 13th to the 18th. That's going to be 5 4s. So I think the C number is going to be the same, and it will just be it just depend on how many A's or B's. So in effect, how many 2s or 3s. Again, that one made me think. That made me think quite a bit. Some of you probably just managed to spot it straight away, but I hope that kind of long-winded explanation helped at least one of you, perhaps. Otherwise, you're just better than me. So I should probably give up, and you should probably just start doing your own help. But anyway, never mind. Let's get cracking. So, this one's a bit easier. So we've got 13a. So we've got 25a over 8 times 2a over 5. Write it as a single fraction in its simplest form. I'm just going to simplify it at the beginning. So how many 5s go into 5? 1. How many 5s in 25? 5. How many 2s in 2? 1. How many 2s in 8? 4. Multiply the tops together. So we've got 5 times 1 is 5. A times a is a squared. 4 times 1 is 4. That should be the answer. And then B, it says Sophia is trying to simplify 6c add 10 over 2. Well, let's just simplify it. Half of 6c is 3c. Half of 10 is 5. Her method is divide 6c by 2. Well, we just did that. Then add 10. Evaluate her method. She is wrong. Should be 3c plus 5. So when you've got a fraction like this, you're dividing the 6c by 2, but you also have to divide the 10 by 2 as well. Okay, is that all that you had to do with that one? Fair enough. Number 14 then. So a rectangle has a length of 60 centimeters and a width of 40 centimeters. The length decreases by 15%. The width decreases by 10%. Sue says the perimeter decreases by 25%. Because 15% and 10% is 25%. Is she correct? Blah, 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 blah. So you just got to break these questions down. So we're talking about the perimeter. So let's work out the overall perimeter of this. Well, it's going to be 60 add 40, add 60, add 40, which is 200 centimeters. So the original kind of perimeter is 200 centimeters. Now, if you decrease something by 15%, the long-winded way of doing it is where you start with 100%. Take off 15%, you get 85%. Turn that into a decimal by dividing by 100, and this is what's called our multiplier. So if I want to decrease the length by 15%, I'm just going to do 60 times 0.85, 60 times 0.85, which gives me 51. I do the same method, to decrease by 10%. So I'm going to do 40 times 0.9 or 90, it doesn't make any difference, equals, probably do that in my head, but I'm not a fool, so I'm going to use a calculator in a calculator exam. So that's going to be 36. Add those two together, because now we've got in effect a rectangle where the length is 51 and the width is 36. So the perimeter there is going to be 51 add 36. Add 51 add 36. I'm just going to times that by 2. And what do I get? I get 174 centimeters. Right? So we've gone from 200 to 174. But she's saying that it decreases by 25%. So any form of percentage change is the change, the difference, divided by the original, and then multiplied by 100. So if we've got the change, 200 take away 174 is 26. The original perimeter was 200. And then I times it by 100 to make it a percentage. So 26 divided by 200 times by 100. We could probably have done that as well in our heads. 13% decrease. And so it says, is she correct? No, she is wrong, as it's a 13% decrease, for example. Okay, so that's how you do that question. Right, where are we? Number 15. So rattling through it so far. Number 15. This is just an inequality. Some people freak out for some reason because the symbol looks a bit weird, but you just solve it in exactly the same way as you would for an equation. Now, I don't like negative x's for some reason. I'm just going to add that to both sides first of all, just to tidy that up. So add x over 3 to both sides. You get x over 3, add 4 is greater than 11. Take away 4 from both sides, you get x over 3 is bigger than 7. Multiply both sides by 3, you get x is bigger than 21. Okay. Number 16. The number of goals scored by 20 players in a season is shown. Work out an estimate for the mean. This should just be bread and butter. You should just know what you're doing with this one. So number of goals, we've got 0 to 4, then we've got 5 to 9, then we've got 10 to 14. The frequency, so how many of them happened? Well, we had 6 games where there were only 0 to 4, 11 games between 5 and 9 goals. Add up all of those and you do indeed get 20. Sometimes they don't tell you. They've been kind and said, well, what's the midpoint? So you've in between 0 and 4 is going to be 2. In between 5 and 9 is 7. In between those is 12. So what we're doing is we're saying, well, if I try and help you, so 6 games had between 0 and 4 goals. Now we don't know whether there were 4 goals, 0 goals, 1 goal, 2. We have no idea. All we know is that in those 6 games, the total number of goals was between 0 and 4. And because we're estimating that, the good estimate to make would be that on average, there were about 2 goals. Some might have had more, some might have had less. So we're estimating by saying, well, let's just assume that they're all a midpoint. Okay, so that's why we're working out the midpoint. And then what we need to do then is do the midpoint times by the frequency. Because we're saying, well, 6 games have on average 2 goals. So 6 times 2 is going to be 12. 11 games had on average 7 goals. So that's going to be 77. And 3 games had on average 12 goals, which is 36. So we add up those number of goals. 36 add 77 add 12, which is 125. And then we're going to do the total number of goals divided by the number of games that we've had to work out the mean number of goals, which is 6.25. It tells us that we have to give it as a decimal, so I'm just going to leave my answer like so. Okay, number 17. Oh, this looks nice. This looks very nice. So let's draw out our rectangle like so. Let's just add some information on. So that's x. This one is x plus 2. This one's 12. This one is also x. Right, so I'm going to put some other bits on. Well, if this whole base is 12, let's just move it up a bit. Let's just refocus so that you can actually see it. So if the base is 12 and the small length is x, hopefully you can see that this bit here must be 12 take away x. Okay, up to this bit. And if this thing is x plus 2, if the height is x plus 2 and we've already got x, hopefully you can see that this small length here must be 2. So it says the area of the shaded rectangle, let's just work that out. Area of shaded is going to be 2 times 12 minus x, which, let's just work it out, is 24 minus 2x. It says the area of the shaded rectangle is a quarter of the area of the large rectangle. So let's work out the area of the large rectangle. And that's going to be 12 times x plus 2, which is going to be 12x plus 24. Have I done this right? 2 lots of that. 24 minus 2x. Have I got this right? Let's go with it. So the area of the small one is 24 minus 2x. The area of the large rectangle is going to be 12 lots of x plus 2, so it'll be 12x plus 24. The area of the shaded rectangle is a quarter of the area of the large rectangle. Work out the value of x. So this bit here, 24 minus 2x, we need 4 lots of that to equal the area of the large one. So we need 4 lots of the small one to equal the large rectangle in effect. So let's see if I can just, what I've got, I could expand this out, or I could just divide everything by 4. So let's just divide everything by 4. And we've got 24 minus 2x equals 3x plus 6. Add 2x to both sides, so you've got 24 equals 5x plus 6. Take away 6, 18 is 5x, divide both sides by 5. 18 divided by, does it tell you to do it as a decimal? 18 divided by 5. I mean, you could leave it as a fraction, or you could just put 3.6. So hopefully that one's helped you. Work out the small one, work out the large one. If it's a quarter of the size of the big one, we need 4 little ones to make the whole big one, and then you just solve it as an equation. Okay, number 18. So number 18 says the pressure in a tyre is 30 pounds for 1 square inch. So I'm going to say 1 inch squared is that. Convert the pressure into kilograms per square centimetre. 1 pound is 0.4. So let's just type, so 1 pound is 0.45 kilograms. We've got 30 pounds. So let's multiply both sides by 30. 0.45 times 30 is 13.5 kilograms. So we've got 13.5 kilograms. And then we've got 1 inch. 1 inch is 2.54 centimeters. Convert the pressure into kilograms per square centimeter. So 1 inch squared, if we draw out a square, 1 inch squared is 1 inch times 1 inch. So that's going to be 1 inch squared. But in centimeters, that's 2.54 centimeters times 2.54 centimeters. So 2.54 squared is 6 point. So 1 inch squared is 6.4516 centimeters squared. And then okay, so with this one, so we've got 30 pounds, but that is being exerted over 6.4516 centimeters squared in effect. So we just want it per square centimetre. So we're going to have to do 13.5 divided by our 6.4516, and that's going to give us the amount of kilograms per 1 square centimetre. We've got it for way more, so we're going to do 13.5 divided by 6.4516, which gives us 2.09. Does it say significant figures? Let's just do it as that. Kilograms per centimetre squared. Okay, where are we now? Number 19. Number 19. Let's just move it up a bit. So number 19, so we've got x is 1 and y equals -3. So let's write this down. X equals 1, y equals -3. Which pair of the inequalities describes a shaded region? So if it's a solid line, it's less than or equal to, and if it's dashed, it's less than or greater than, for example. So we want, if you've got your axes like this, so we've got our x and our y, we want the bits to the left of x equals 1. So x is going to have to be less than 1. And then we've got all of the bits, if we've got our y line here, we want the bits greater. So that, in fact, yeah, the numbers of y, because that's going to be -3, -2, -1, 0, 1, 2. We want the numbers bigger than -3. So it'll be y is bigger than -3. But let's just check our dashed or our dotted. In fact, they're both dashed. So it's both going to be bigger than or less than. So that is going to be it, which I think is going to be our second option down. Okay, let's see if I can get another question in at the bottom of this page. Amari and Ben each play a game. Lowest is 12, highest is 20, lower quartile, upper quartile. Right, this is just straightforward, all right? I'm not going to copy out the grid, but a box plot looks like this. Sometimes it's called a box and whisker diagram. Should be fairly self-explanatory. Why? This is the minimum value. This is the maximum value. The line in the middle of the box is the median. The kind of left-hand side of the box is the lower quartile, and the right-hand side of the box is the upper quartile. Now, in this example, it's just fairly straightforward. They give you every single value to just plot. In some of them, what they give you is a lower quartile, and then they tell you what the interquartile range is. Now, the interquartile range is the difference between the lower quartile and the upper quartile. So say they gave you the lower quartile and then they told you the interquartile range, you would simply add that on and then it would give you your upper quartile value that you could plot. Okay, so that's what you would do there. Now for part B, it says, this box plot represents Ben's scores. Work out who had greater consistency. Now if they talk about consistency, that is referring to the interquartile range. So the difference between the upper quartile and the lower quartile, in effect the middle 50% of your data. So let's work it out for Ben whilst that's in front of us. So we've got an upper quartile of 15, a lower quartile of 12. So the interquartile range for Ben is 3. And then is it for Amari? Is that her name? For Amari, the upper quartile is 19, the lower quartile is 13, so her interquartile range is 6. Now, with consistency, you want the kind of interquartile range to be as small as possible, because that would mean most of your scores are very, very close together. So who's most consistent? Ben as IQR smallest. Okay, so Ben as he's got a smaller interquartile range, and you can just leave it as IQR rather than writing interquartile range. That takes forever. Okay, good. Where are we now? 21. Okay, so circle theorems. 21 and a bit of triangles to be fair as well. So if you've got your circle, let's just try and draw it out. So we've got our lines like this. We've got an angle here of 71. A and B are points on a circle. So we've got A, B and P, not C. So we've got A, B and C. A, B and P again, sorry. So these are tangents. So if you know they're tangents, they must be the same length. And therefore, you must know that this is an isosceles triangle. So if that's 71 degrees, that must be 71 degrees. 2 lots of 71 is 142. Angles in a triangle add up to 180. 180 take away 142. Why would I want to work it out without typing it into my calculator? Who knows? 38 degrees. So I believe that angle APB, this one here, must be 38 degrees. 21B, if you've got an arrowhead, anywhere, I mean, it could be literally anywhere. So you've got the center here. This angle, let's call it x, is half of this angle. All right, so you've just got to remember that. So in effect, if this one here is 78, if I double that, 78 times 2 is 156. But we've not been given this angle, we've been given this one around here. And if I do 156 add 204, it should be 360 if that is drawn correctly, if x is the center. And it does. 156 add 204 does give me 360. So I can say yes, x must be center as angle at center twice that of angle at circumference. Something like that. Right? Good. 22. Okay, this looks complicated, but I'm pretty sure it'll be okay. So visitors to a museum buy a child ticket or an adult ticket. Here's some information about two groups. So let's say group X, group Y. Group X has 250 visitors, 120 children, and it's child or adult. So let's work out there's going to be 130 adults. In group Y, the number of children to the number of adults is in the ratio 17 to 15. Okay, so overall we've got 32 parts because I've just added those two together. So it says one visitor from each group is picked at random. Is this statement correct? So the probability of picking two children, so let's work that out. So if I pick a child from this group, it's going to be 120 out of 250. And because I'm timesing, I'm saying this and this, I need to multiply them together. So probability of a child from group X is that. The probability of getting a child from this group Y is going to be 17 over 32. So we've got 120 over 250 times 17 over 32. And if I type that in, I get 0.255. Now the probability of getting two adults, so from the first group it's going to be 130 over 250 multiplied by 15 over 32. So I'm just going to use the cursor so that I don't have to type the whole thing in again. 130 over 250, this time multiplied by 15 over 32, gives me 0.24375. So it says the probability of picking two children is bigger than the probability of picking two adults. So when you're comparing decimals, just add in the zeros. 255 to, yes, it is. Yes, as 0.255 is greater than 0.24375. Done. 23 vectors. Nice, and I was going to say easy. Sometimes they're quite difficult, but if you just follow a process, you should hopefully find them okay. So let's just copy this triangle out to see if that helps us. So we've got J, then we've got K, then we've got L. You need, because vectors have a size and a direction, the arrows are important. So we've got N somewhere along here, and that one is 4B, and M looks like the midpoint, and it says yes, so M is the midpoint. J to N, so J to N is 3 parts and N to L is 2 parts. So overall, this bit here is 2 parts. So I'm going to split that into 2, and this one is 3 parts. So we've got 1, 2, 3, 4, 5. So overall, we've got 5 parts. Now I'm told that between N and L is 4B, and that represents 2 parts. So I can write each part must be 2B. Okay, and that's going to help me, presumably later in a question. It says work out J to M in terms of A and B. Well, first of all, let's work out how we can get there. We can only go along the paths that we know. So how am I going to work that out? Well, what I'm going to say is J to M is half of J to K. And how do I work out what JK is? Well, let's work that out. So let's put that in brackets. Let's save that for later. So how do we get from J to K? Well, each one of these is 2B, and there's 5 lots of them. So it's going to be J to L plus L to K. I've just said that JL is going to be 10B, and LK, because I'm going opposite to that arrow, it's going to be minus my vector. So it's going to be 10B minus 7A. Now, that's what JK is, but I want half of JK. So JM is half of 10B minus 7A, which is 5B minus 7 over 2A. And I don't think you can simplify that anymore. So that's what you do. So break it down into the journeys that you know, the ratio bit, work out what one part is, and then multiply it up to work that out. And if you go against the arrow, you need to make that vector negative. So hopefully that one helped you with this one. 24 then. So let's have a look at this. A and B are points on a curve. A is 2, 7, B is 12. Work out an instantaneous rate of change with y with respect to x at point A. So if you've got your thing that looks like this, something like that, I mean that's terrible, but you hopefully get the idea. And our point A, in fact, our point A is somewhere here, isn't it? So that's A. We've got B at the bottom, and it says work out the instantaneous rate of change. Now my diagram's not great, but what you need to do is you need to get a ruler. And because it's instantaneous, you want the gradient at that specific point. Now, how are you going to work out the gradient at that specific point? You can't draw like a really tiny triangle. It's going to be so inaccurate. So how are we going to make a big triangle? Well, you get your ruler. I mean, that is literally terrible. But you should hopefully, let's see if I can draw it a bit better. So let's say that's A there. I want to get my ruler, and I want a tangent. In fact, that's not too bad. So we've got our tangent at A. And then I can draw a big triangle this time, and then I can work out the gradient of the point at A. Okay, so instantaneous rate of change. What's the gradient at that point specifically? I'm going to need to draw a tangent. I draw myself a fairly large triangle. I work out the value of x. I work out the value of y. So this change and this change. And then, as you know, the gradient is the change in y divided by the change in x. I'm not giving you an answer because everyone's going to have a slightly different version, but if you do this, then you will get the answer correct. It then says the average rate of change of y with respect to x between A and B is worked out. Which statement is correct? This one is a bit annoying. So say you've got your shape like that. A is here and B is all the way down here. And what's the average rate of change? Well, this is the top, isn't it? So what's the average rate of change? Well, remember, if we've got an instantaneous rate of change along these points, imagine you've got like loads of tangents. You've got loads of tangents from A to the maximum point here. But if it was symmetrical, if B was over here, you'd have the same number of tangents, wouldn't you? Because it would just be symmetrical. The same number of points along this line, along this curve, to the maximum would be the same as the same points along here to B. But B's way further down here. So all of these values are positive because it's a positive gradient. All of these values are negative. So it would be 0 if it was symmetrical because all of the positives would cancel out with all the negatives. But we've got way more negatives. We've got all of these gradients that don't exist on the left-hand side. So if we've got way more negative gradients than positive gradients, overall it has to be negative. So it's going to be negative. Okay, where are we at now? This is straightforward. Okay, you just need to know the equation of a circle. The equation of a circle at GCSE, x squared plus y squared equals the radius squared. So we've got x squared plus y squared equals 9. The radius squared is 9. The radius is 3. But be careful, they've asked for the diameter. So if we've got a radius of 3, the other side must be 3. So overall, it's going to be 6. Okay, so we've got a radius of 6. Okay, next one. Sorry, we've got a diameter of 6. Next one. I love these questions. It's just a procedure. Okay, so with recurring decimals, the way that I say it is how many digits recur. So how many digits are repeated? So in this question here, we've got 3.47 recurring. So that just means that one digit recurs. So with recurring decimals, if one digit recurs, you just find 10x. If 2 digits recur, you find 100x. If 3 digits recur, you find 1000x, and you've got the idea. But what do I mean by that? Well, when you've got a recurring decimal, you make this number and you just say, well, let x be that number. So 3.47777 and so on. We've got one digit that recurs, so I'm just going to find 10x. And the crucial bit is that you want your decimal point to line up. There are no squares in your exam paper. So this is the hardest bit of getting this question correct. If you multiply all of this by 10, the numbers just shift one space to the left. And this is where the trick comes in. Can you see that after this point, all of the 7s line up with all of the 7s? So what we can say is well, 10x take away 1x is 9x. And then I've got 34.7 take away 3.4. So again, I use my calculator. 34.7 take away 3.4 gives me 31.3. So 9x equals 31.3. So then what I can do is I can divide both sides by 9, and I get my fraction, 31.3 over 9. But you don't want decimals in a fraction, so you can just keep multiplying by 10 on the numerator and the denominator until you remove your decimals. And in fact, that's all we had to do to get our answer. Okay, so I hope that that helped you with the recurring decimals. This one, y equals x minus 1 squared minus 6. Circle the coordinates of the turning point. Okay, well, what we want to do is we want to say, well, what is, let's say this is the graph, right? So I just know that it's going to be crossing at this point. So it's going to look something like that. Now, how do I know that that quadratic looks like that? Well, I say, well, what's the minimum point going to be? What's the smallest value of y? And the smallest value of y is when this thing equals 0. And when does it equal 0? Well, I need this bracket to equal 0. And that bracket only equals 0 when x is 1. So when x is 1, this is the smallest value. 1 minus 1 is 0. 0 squared is 0. So when x is 1, y is minus 6. So the coordinates must be 1 minus 6. Have I got enough room for 28? No, I haven't. This one looks like a bit of a beast. So let's go up here. So 28, equation of a line is y equals 4x minus 1. It's perpendicular, so line B is perpendicular. It passes through that point. Work out the coordinates where it intersects the x-axis. Okay, so y equals mx plus c. The gradient of this line is 4. If it's perpendicular, then the gradient is the negative reciprocal. So we've got y equals minus a quarter x plus c. How do I work out what c is? I need an x and a y coordinate. So I need a point that it passes through. Well, luckily I'm told that it passes through 8, 5. So my y coordinate is 5. My x coordinate is 8. So I can rearrange this. So minus a quarter times 8 is minus 2. So c, I believe, must be 7. So my line must be y equals minus a quarter x plus 7. But what I'm told is, so if I just draw this out to help you visualize it, the y-intercept is 7 and the gradient's minus a quarter. So it's going to look something like that. I'm asked, what are the coordinates of where it crosses the x-axis? So if we've got our equation y equals minus a quarter x plus 7, hopefully you know that where it crosses the x-axis, the y value must be 0. So 0 equals minus a quarter x plus 7. I don't like those negative x's, remember. So if we add that to both sides, we get a quarter x equals 7 times both sides by the 4, and you get 28. So the x coordinate here must be 28, but we're asked for a coordinate, so it must be 28, 0. Okay, can I fit the last question onto this page? So 5 marks. Wow. So let's have a look, see if we can do this one. Shape is made by joining, so let's see if I can draw it slightly smaller. So we've got A, B, C, that's 114, that's 8, that's 6, sorry, that's 10, and we've got a semicircle, okay, and the diameter is AC. Work out the total area of the shape. Wow. There's 2 bits to this. We first of all need to work out the area of the triangle, then we need to work out the area of the circle. The area of the triangle doesn't have a right angle, so you should hopefully know that it's half AB sine C. AB are just your lengths either side of your angle, so half of 8 times 10 times sine 114. If I just type that into my calculator, so 0.5 times 8 times 10 times sine 114 gives me 36.541818131. I'm just going to leave the decimal places until right at the end. Now, to work out the area of a circle, we need pi r squared. But I don't know what this length is in this circle. So what I'm going to have to do is I'm going to have to use the cosine rule to work out what the length of this diameter is. Now, if you don't know how to do that, or how you know, or how I knew that I should use the cosine rule, check out my video. It says I've got a triangle, but I don't know what on earth to do. So that tells you kind of in simplistic way why I know that that's the cosine rule. But anyway, the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. The length that I want to work out, I'm going to call a, and then you can just bin off all your other letters. All right, so we've got a squared equals, as long as b and c correspond, so we've got 8 squared plus 10 squared minus 2 times 8 times 10 times cos of my angle that's opposite a. So then if I type all of this in, so if I just do, hopefully you can see all of this, so if I just do 8 squared plus 10 squared minus 2 times 8 times 10 times cos 114, a squared is going to be 229.077 and so on. I'm going to keep that in my calculator and I'm going to square root it. So I do the square root of my answer equals 15.1 something. So a is 15 point, and again I'm going to keep the decimal places for now. Some of you might have a trick to remember it in your calculator. I don't know how to do that, but well done if you do. So that's the diameter, but to work out the area of a circle I just want the radius. So I'm going to do area is pi times the radius squared, and I'm going to divide it by 2 because it's a semicircle. Now I'm going to see, I've done loads of this, so it's probably a bad thing to just show you what I would do. So I've got my diameter, I'm going to divide it by 2, so now that's my answer. So I'm going to do pi times 7.5 something squared over 2, and again I'm going to just put my answer because it remembers my previous answer, so my pi times the radius squared divided by 2 gives me 89.95. Bam, 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 bam. I'm running out of room, so I've got this, add my now other answer, so I'm going to do 36.5 add 89 point whatever it is, and so that plus 36.541818131, and you get 126.5 to 1 decimal place, and the units are centimeters squared. So that's a bit of a beast. You've got area of a triangle using the sine rule. You've got the cosine rule to work out the diameter. You've then got your area of the triangle using the radius, and then you add those two bits together. So that's a bit of a beast, but I hope those steps helped you, and I hope that this video was useful, because I think, in fact, there's one more question. You moron, I thought I was done, but there's one more. So let's see. In fact, are there more? No, this is the last question. So let's have a look at this one. So f of x equals half x, g of x equals x minus x squared. Oh, this is a bit of a pain, isn't it? F of minus 1x. So we want to work out the inverse function. So what you do is you say y equals half x, and then to work out the inverse function, you make x the subject. So it will be 2y equals x. So then you say, but my inverse function is just, you just swap these around, so it'll just be 2x. So we've got, oh wow, this is a bit of a pain. So then f of x going into g of x. So when you've got g f of x, you keep working to the left. So we're going to put all of f of x into g. So g of x says x minus x squared. F of x is half x, so it's going to be half x minus half x squared. So it's a half x. Half x squared is going to be a quarter x squared. Okay, so that's what that's what g f of x is. And we need to say, well, 2x equals that. So 2x equals half x minus a quarter x squared. Oh, wow. I don't like these fractions, so I'm going to multiply by the biggest denominator. So if I times everything by 4, I get 8x equals 2x minus x squared. Rearrange this to make rearrange this to make it equal to 0. I don't like negative x's over here, negative x squared. So we're going to have x squared plus 6x equals 0. Factorize that out, you get x brackets x plus 6 equals 0. So x equals 0, or x equals minus 6. And I believe that is that. So hopefully I've done that correctly. I hope this video was useful. If it was, drop it a like, pass it to your friends, let your friends know that these exist, and hopefully I'll be producing more videos, so subscribe, and then you'll be the first to hear about them when they are launched. Over and out.